Hello everyone, welcome to Nrcm, and I'm going to speak about operating system of Unit 2, and today's topics are like what are the different types of operations on process, and these operations are like process preemption, process blocking, termination, and we'll discuss about cooperating process as well. So coming to the operations on process, so there are several operations on the process. So first is like process creation is one kind of operation, and process preemption, process blocking, and then process termination. So these are the different operations which are performed on the process. So first coming to the process creation. So the process is created with the help of the fork system call, and the process can be, once the process is created, it can create its child process also. So the created process is called as parent process, and the process which is created by its parent process, or you can say simply the creating process is called as parent process, and the created process is called as the child process. So here, after execution of the child process, the parent process might execute, and this parent process and child process, both of them will be having the same kind of image which we have discussed in the previous session. And if the parent process has to be terminated, so the first initially the child process has to be terminated, then only the parent process can terminate. And next point is like a child will be having only one parent, but the parent can have n number of the children. Okay, this is all about the process creation. So next will be moving to the process preemption. So what is process preemption? So preemption is nothing but in general, like we can say preempting, like it is a mechanism to suspend the process. It is a mechanism to suspend the process, or it is a mechanism to suspend a process which is currently executing. That is called as process preemption. And then the new process or the next process will be executed, and this is determined by the short time scheduler. So this process preemption will be determined by the short term scheduler. So here preemption makes sure that all the process get some CPU time for execution. So this is responsible for, like, all the process should get the resources equally. So initially we all know that if the process is loaded into the main memory, then the process will be into the ready state. If it is ready to execute, then it will be in ready state. So if the process is ready to execute, so it will be, and then after, once it is ready, then it will be going into the running state. So during the running state, if any of the new process arrives here, which is having with the highest priority, so then what happens, the executing process, it will be entering again into the, or you can say it is preempted and entered into the ready state again. So once the highest priority process is executed, then again the old process which is present in the ready queue will be dispatched into the running state. This is all about a process preemption. Next, speaking about the process blocking. Like in general, like we can say process blocking, or the process is blocked if it is in waiting stage, or if it is waiting for some event to occur. This event may be input output event, which have been executed in the main memory, and which this input output event, it doesn't require any kind of process to execute. So after the event is complete, the process again goes to the ready state. Again from ready to ready state, it will be dispatching to the running state. So suppose I wanted to give you the general example. If the process P1 is in ready state, so it has got it, once it is ready, it has been dispatched and it is in running state. It is executing. So in the middle of the execution, it requires some input output operations. It requires some input output operations. Then, so there is no need of this CPU, but it requires some input output operations. So this process will be coming and moving to the waiting stage. This is called as waiting stage or block state also. So, and after once the input output requirement is finished, then again the process will be moved back to the ready state, and from ready to ready state, it will be moved to the running state. So this is all about the process blocking. So next we are going to discuss about the process termination. So once a process is created, it has to be terminated. the process, after the process has completed the execution of its last instruction, it will be terminated. And the resources, if the process while executing the program, if it handles any of the resources, they are released after its termination. So and suppose if any child process, if any of the child process can be terminated by its parent process if its task is no longer relevant. So in case if there is child process but it is not, it is no more of it is it completed its task, then parent process can be terminated. If it is doesn't perform any task, then the parent process can terminate it. And one more thing is like the child process sends its status information to its parent process before it terminates. Okay, I hope you are understood. And also when the parent process is terminated, its child processes are terminated immediately, as well as the child process cannot run if the parent process are terminated. Once a parent is terminated, the child's will be, obviously they will be terminated too. Okay, this is all about process termination methods. And next we are going to the next point, next topic, that is called as cooperating processes. Generally, there are two kinds of processes. One is cooperating process and second one is independent process. A process which is independent means which doesn't require any shared memory or any resources, or if it cannot affect or be affected by any other process, that kind of process is said like it is cooperating process. Okay, or if any of the process which is affected or to be affected by another process, the system, and a process that shares data with other process is called as a cooperating process. Okay, in simple, I want to tell cooperating process are like nothing but they will be communicating with other process, and they can use shared memory or distributed memory, or they can share the data. But coming to the independent process, they won't share the data, they will be working on the distributed memory only. They won't share the data, share the resources or any kind of the variables. Okay, this is all about the cooperating process, and there are some advantages in this cooperating process. So we can see, like if we are going with the cooperating processes, the advantages will be like information sharing. Yes, this is the biggest advantage. Like if the process are having the same information, or if the process requires the same information, like if they want to share the common file, so the operating system needs to provide a way for allowing this concurrent access. Okay, so next is modularity. So the biggest advantage of this cooperating process is the solution of the problem is it is structured into parts with well-defined interfaces and where the parts run in parallel. As all the parts will run in the parallel, or different processes will be running in the parallel, so so it will be like that it will be time saving and the computation speed will be increased. And if any of the one of the module is affected, or if any of the process is affected, the other modules or process will not be affected, or they will be unaffected. And one more advantage we can give, it's the convenience. So by using this cooperating process, it is very convenient. Like a user may be running in the multiple processes to achieve a single goal, right, nowadays. So or where it may invoke multiple components in the process. It may invoke multiple components, so which interconnect via pipe structure that attaches the std out of one stage to std in of the next stage. Okay, and if we allow process to execute concurrently and share data, then we must either provide some mechanism to handle conflicts also. That is writing and reading the same piece of the data within the same file. We must also be prepared to handle the inconsistent or corrupted data. So I think this will act as a disadvantage in this cooperating process. So this is all about the cooperating process. So it will share and it will communicate with the other process, and it will share the data. So this is all about the cooperating process. And thank you. We'll continue with the next video class.